Hello students, welcome back. We completed first two problems. They are all about normal distribution, the mean of 62 miles per hour, and the standard deviation of 4.95 miles per hour. 1.3 is a little bit different. What is the standard deviation? Which means I don't know standard deviation anymore. So this one is completely different from 4.95, which was repeated here. It's gonna be a little bit different number. So what do I have to do to find out the standard deviation? As a matter of fact, if you draw the picture and set up the z-score formula, that question will answer itself. You're gonna get a certain equation, and that equation is not too difficult to solve. Okay, as usual, let's begin with drawing a picture. If you don't draw the picture, you can do it, yes, but it's going to be much harder that way and a bit more confusing. Also, in the exam, I require the drawing. In homeworks, I give you a little bit more freedom because you're just learning all these. But in the exam, by that time, I assume everybody can draw appropriate picture. So if you don't practice here, you're going to pay dearly in the exam. Okay, how do you draw a picture? The same deal. Outline, center, end, and then shading. Outline the same, center, again 62 miles per hour. What's the end in this problem? For this particular problem, what is the end? That's the other number, isn't it? 72. And that should come to the right of the mean of 62. 72 is bigger, so it comes to the right. And here's a picture. 3% of the automobiles travel faster than 72%. So this part over here, which is shaded in red in this case, corresponds to 3%. So by default, to the left, 97%. Makes sense? 0.03 here, 0.97 here to the left. If you have only one color, then you can shade either one. Shade here and then 3%, or shade over here to the left and then get 97. Either way is going to be okay. What I usually do, I shade to the left and get 97% and then look up 97% from the table. Why? Because if you look up the normal table, normal tables are always shaded to the left, like this. So it's going to be a little bit more convenient if you get the shading to the left, but it doesn't matter as a matter of fact. Even if you shade to the right, the red part, you can clearly see this is 97%. Now, if you do get 3% and look up 3% from your table and get your answer, you can still make it work by changing the sign appropriately. No problem there. Okay, all right. Let's go to 97%. And let's look up 97% somewhere here. 0.9700, or the closest to it. To me, this one's the closest. 0.9699. That's 1.88. Do you see it? 1.88. That's where we have 9699. 9706 is a bit too far away. So let's take 1.88. So that's what your z-score is. So z is equal to n minus center over SD. And that's approximately equal to 1.88. Does it make sense here? This one is 3%, that's 97%. So the z-score should be 1.88, coming from the z table there. You see, 97% comes from here where my mouse is running around. That's the closest. And if you backtrace, you get z-score of 1.88. That's your z-score. And What do you want to find out? Standard deviation. That's what you don't know, so that's what you want to find out. Let's see. So end is 72, center is 62, and then the standard deviation, I don't know that. From here, you can solve this equation and find SD. It's just an algebra exercise. And here we go. Down here equals. So all you have to do is exchange these two. Font is a bit too small there. So let me copy and paste this one. And then go from there. Let's see, 72 minus 62, so we have 10.0. And then here, what I'm going to do now here is multiply by SD, divided by 1.88, multiply that. And if you multiply by the same thing to both numerator and same thing to left-hand side and right-hand side, excuse me, then what do you get? Okay, standard deviation, they're going to cancel each other out. 1.88, 1.88, they're going to cancel each other out. I'm going to get 10 divided 1.88 is approximately equal to the standard deviation. And all you have to do is this computation. $5.391. That's what I'm getting. Approximately speaking, above 5.32. Yeah, about that. That's what I got from primitive Z table. And if I use fancy mathematical computation, then I'm going to add more decimal digits, of course, because I can do it more accurately. And a little bit more accurate computation yields 5.3169. And we have 5.317. Okay, 5.32 is acceptable, but this computation yielded a little bit better number here. Well, either way it's acceptable, but from this point on, let's use 5.317 because this one gives me a little bit more accuracy, so I'll use this one. If you use this for next two problems, that's going to be okay. Either way, it's going to be fine. Remember, I'm the one who's going to grade these problems, not machine. So I'm going to be tolerant on these kind of rounding errors, which are inevitable in any kind of statistics. And if you deal with those machine graders, then very often they count correct answers differ by a little bit of a rounding as completely wrong answer and cause bigger confusion. I'm afraid my MATLAB also has this problem, but we don't have much choice unless we get some drastic improvement in AI quality for those publisher software. At this moment, we don't have those. For these kind of problem, I'm not a machine. I'm going to grade, so I can grade as fairly and generously as possible. In any case, the key part is the picture and this equation. How to solve that equation? Well, we need some algebraic skills, but then again, well, this is actually elementary algebra or even below. Not even intermediate algebra, so I don't think this will cause too much trouble to anybody. So I'm going to leave the detail to the students, and we'll say 1.3 is done. Now, do I have time for 1.4 and 1.5? No, let's stop here.